In this section, we're going to get away from equations and look at inequalities. So, whereas the solution to a linear equation is just a single value, if we have an inequality, the solution is going to be a range of values, usually greater than or less than, or maybe greater and less than a value or some multiple values. So many solutions, an infinite number of solutions, rather than just one solution like we see in an equation, except but the steps that we will take to solve an inequality are pretty much identical to solving equations. One other difference is that we will graph solutions to inequalities. So a quick little warm-up, let's graph these inequalities. So let's say we have x is less than 3. So we have our number line. These are just going to be one variable, so we're okay to graph these just on a number line. We're not graphing these on a coordinate plane. We'll do that next chapter. But x is less than 3. I'm fine with very minimal graphs as long as we show all the information that we need. So we have a number line. The only value that matters is 3. At 3, we could put either an open dot or a closed dot. When it's just less than, we will put an open dot. Since we are not including 3, 3 is not a solution. The statement that 3 is less than 3 is false, so we don't want to include 3, so we use an open dot, and then we want the values less than 3, so we would shade to the left. Let's graph x is greater than or equal to -5. So again, number line, our only important value is -5. If you want, you could add -4, you could add -6 on either side. But we are greater than or equal to -5, so we will have a closed dot at -5, and the values greater than that are off to the right. On this next example, we have a compound inequality. So we've got two inequalities in one statement. So this is telling us that -4 is less than x and x is less than 6. So we've got -4 over here, we've got 6 over there. X has to be greater than the -4, so an open dot there. And x has to be greater than that, but it also has to be less than 6, so an open dot at 6, and to the left of that. So our solution is all of the values between -4 and 6. Last one, we have another compound inequality, but this one has an OR. So this one, x is greater than or equal to 2, or x is less than a -7. So our lower number is a -7, and our greater number is 2. We want to be greater than or equal to 2, so equal to 2, so a closed dot there. And we want to be greater than that, so that's to the right of 2. Or our values can be less than, so open dot at -7, less than -7. So open dot at -7, and we would shade over to the left. So an AND is going to meet in the middle. It's going to be between two values. And OR will be shaded outward, because it can't be greater than 2 and less than -7. So those few examples were what the solutions might look like, and then how we would graph the solutions. So we haven't solved any inequalities yet. When we solve inequalities, it'll look just like an equation, except you have an inequality sign. And the steps that we take when it comes to adding things or subtracting things across or multiplying or dividing, everything works exactly the same as when we have an equation, except for when we multiply or divide by a negative. Do you remember what happens if we have an inequality and we multiply or divide by a negative? So let's consider this example down here. If we have -x is greater than 2, I need to get rid of that negative. So let's say I divide by -1. That would give me x. That would give me 2. but then something happens in the middle. So let's look at this a little bit different way. There's another way that I could get the x to be positive, and that's by adding x to both sides. And then I would subtract 2 from both sides. And so now what I have is negative 2 is greater than x, or if we flip that, the x has to be less than the negative 2. Sorry, back to that thing on the left. We should have, over here we should have x and then our blank, and then that should be a negative 2, right? So how should that x and negative 2 compare over here? Well, it's not going to be greater than, right? That's different than what we saw here. So this actually ends up having to be x is less than negative 2. So remember that when we multiply or divide by a negative, we have to flip, I can rewrite that, flip the inequality. Okay, and it's only when it's by a negative. If we divide by a positive 2, or if I multiply by a positive 3, I don't have to flip the sign. Only when I multiply or divide by a negative. So let's do a couple examples all the way through together. So this first one, we have 4x plus 3 is less than or equal to 6x minus 5. Doesn't matter how we go about doing this. Let's get our x on the left side. So let's subtract 6x. And if we want, on the same step, we could move the constant. So let's subtract 3 from both sides. So 4 minus 6x is going to give us negative 2x is less than or equal to negative 5 minus 3 is going to be a negative 8. So our last step, divide by negative 2. And we end up with x is greater than or equal to, so this is where we flip the sign since we divided by a negative. X is greater than or equal to a positive 4. So that's our solution. But then we can represent that solution with a graph. So 4, 5, and 3, closed dot, right, because we're greater than or equal to 4, and then shaded to the right. So we'll do this next example together. So here we have a compound inequality, and you're just going to treat this like there's 3 sides of an equation. So we want to solve for the x with the 3x plus 5. So we're going to subtract 5, and we need to do that in all 3 sections. So on the left we have negative 15 is less than 3x is less than or equal to 3. And then we divide by 3 on each section. So a negative 15 divided by 3 gets us a negative 5 is less than x is less than 1. So again, here's our solution. And we can represent that solution on a number line. So negative 5 is our lower value, positive 1 is our upper value. We're less than, x is greater than a negative 5, so we're to the right of the negative 5. But we also have to be less than 1, so open circle at each of those, and then it's the space between those values. Okay. And then we'll talk about this third example, and you can finish it up on your own. For this, you need to solve each of these on their own. So on this left one, 2x minus 1 is less than or equal to negative 7. You would add 1, divide by 2, and you'll have x is less than or equal to something. And over here, subtract 3, divide by 4. You end up with x is greater than or equal to something. So you have x is less than this, or x is greater than this. And that looks just like what we had on the last slide, where you'll have the 2 branches opening out away from each other, since this is an OR.